Good afternoon, everyone. So everyone, if you cannot hear me, can you just wave your hand or something else? Should we start on time? In about 6 minutes. We have like 25 participants today, and our presenter is already here. Okay, more people coming. Okay, let me check whether everyone can hear me clearly. Now I'm waving my hands. So if you can hear me, can you just wave your hand, like do like this? If you can hear me, can you do like this? Okay, thank you. Okay, so I hope everyone in this room is ready for the very interesting webinar today. Okay, we are about to begin. I will wait for a few minutes so we can start on time. Okay. Good afternoon, everyone. I think it's time to begin our webinar. Let me introduce myself again. I'm Sincal from Kasetsart University. And let me introduce you our presenter, Dr. Cuong Nguyen Mao. Okay, can you just wave your hand, Dr. Cuong? Dr. Mao? Okay.
Good afternoon. Good afternoon.
Okay. Today, our webinar is about comprehensive financial technical planning and design of microgrid, which is a very interesting topic because today we pay attention a lot about how to develop the microgrid in our smart and modern system. And actually, there are many interesting topics that relates to the microgrid technology. And today, Dr. Mao will discuss just some interesting and maybe you can make use of it later about the microgrid. Today, Dr. Mao, which is the head of Siemens PTI Southeast Asia, and he will briefly introduce himself and he will discuss about the topic today. Anyway, to let the webinar to the end smoothly. So maybe if you have question or something that you want to ask, you may type it in the message or you keep it at the end of the presentation and we will discuss about all questions later at the end. Okay. Okay, I will give this to the Dr. Mao to start the presentation.
Thank you, Dr. Chandai. Good afternoon to everyone. Welcome to my presentation about the comprehensive financial, technical planning and design of microgrid. So, short introduction about me. I work for Siemens Power Technology International, and we have 26 offices worldwide. And we have in Southeast Asia, we have office located in Bangkok, Thailand, and we are the consulting department of Siemens. So I work in Germany in headquarters about 6 years before I moved to the office in Bangkok. Okay, to start the presentation. Sorry. So this is the content of our presentation. There are three clear topics. So firstly is financial. The second is technical, and the third is control. Control here is also including the monitoring. And so as far as you know that microgrid is let's say like scaled down power system. So that means that's the power system with a smaller size and included generator, but the distributed resource and also the consumer load locally. And microgrid can connect to the public grid, or it can be isolated or islanded into from the local utility or from local public network. So you know that microgrid include many components. You can see here the photovoltaics or wind, is renewable energy, or it can buy the gas turbine, fuel cell. You can have the backup generation set, or you can have the energy storage. Energy storage may be in thermal or in electrical. You have load and you have connecting point to the utility grid, and this is a point of common coupling here. It can be open or can be closed. to be connected to grid or isolated to the grid. And so this could be the colleague or business park or Indian reservation casino, industrial plant, military base. This is all we personal know. Yeah. So when we talk about when we start to planning the microgrid, so what is the KPI? Let's say financial for who importance. So let's say if we talk about the developer, so they will pay attention about levelized cost of energy, return of equity, so internal rate of return, CAPEX, OPEX. If you for the CEO, they will pay attention about return of equity, levelized cost of energy, CO2 emission, CAPEX. For CFO, for financial officer, saving per year, levelized cost of energy, CAPEX, OPEX, or for sustainable office, they will think about how much of CO2 emission, how much can we reduce the fuel consumption. And for production plan manager, they take care about the reliability, redundancy, and -1 landing operating reserve. And for energy plan manager, so they take care, they want to know about how the fuel consumption reduction, redundancy, operating reserve. How can we replace the diesel? How we can control the diesel, and how is the grid control? So all of this here, you can see KPI here is come from financial KPI and also from technical KPI. And that's why we need to have a comprehensive study, investigate, to give to each pupil here have the clear picture about the microgrid project we be invest in near future. And moreover here, so this is like tendency. So you can see here in the left side here, the tendency when we integrate the renewable energies. No? So the renewable share here is the vertical axis, and the horizontal axis is the percent between the renewable energy and the load. And you can see here the tendency is without energy storage system. So normally for wind, we can integrate maximum from 25 to 30%. For solar, we can integrate about 10 to 15% of PV, but without energy storage. But with energy storage, we can integrate, let's say, increase the share of wind to 65 to or 70%, or solar can be 25 to 33%. This is tendency. And if we come to the, let's say, the relative comparison, this is the return of invest and NPV. And return of invest here, if you integrate wind 40% or solar 30%, we can have the higher return of invest if you invest the 110% to 140% wind, and solar 130 and 160%. But NPV is different. NPV is here, in this case, the NPV is lower than higher share of wind. So why I show this slide? Because to have the first impress how is the impact of the share of the renewable share to the financial KPI. So now we go to in more detail. So how can we how can we, let's say, make the comprehensive approach or study when we start planning the microgrid? So here is what Siemens what we can offer. That we first start with the in-house sizing tool. So we call it the PSDE. So what is the outcome of PSDE? We will go into the detail in the next slide, but the outcome of PSDE will be the financial evaluation. So after we have the financial evaluation of different scenario, then we will select the most suitable scenario based on the requirement or expectation of different stakeholder and so on. And then we move to the next step is the technical verification. So in the software called is PSS Sincal. Here we focus on whether our microgrid in electrical point of view, it can be operate smoothly, can operate stable in let's say in different load flow scenario and in different contingency, and also in the different in the point of view of power quality. And after we verify this, let's say we start to build the network on site, but we need the control. So here the next step here is how can we control our microgrid, and not only control but also monitoring. And also for monitoring, we can compare the measurement result with the planning result. And if there is any deviation between measurement result and planning results, then we need to have the fine tuning. So this will be done in performance guarantee. Performance guarantee, we take care of this, but it will be in the tool of MGC or MGMS. It will be discussed in next slide. Okay, we go into detail in the first content about financial. So this is this one. This is first step, very first step. So normally when you have the microgrid, you please take a look here in the left side. In the left side here, you have first box here is current customer situation. So let's say, for example, your microgrid now is maybe greenfield, or maybe your microgrid now have only diesel generator. And how is the load? And next is how is generator, how is the load, is how is the potential of solar and potential of wind. What is the load profile, and what is the limit? So what is the fuel type you using, the oil or gas? What is the reserve upgrade of the generator and other contract, other PPA? And what is the fuel consumption, energy cost? How many cents per kilowatt hour? How is the cost of start and stop? And how is the cost for maintenance? And from that, we need to go to model, the system model, generator, load, PV. We need to model load profile, weather profile, the limit. And then we have some parameter adaptation. Let's say, take into account the fluctuation, let's say in inflation, or the cost increasing, let's say 2% per year, and so on. All here take into account, and then we create out the different scenario, and each scenario here we calculate the CAPEX, OPEX, fuel and consumption, energy cost, and lifetime, and so on. And we compare. So this is already correspond to the customer information? If yes, so we make a loop, and if no, we change the parameter adaptation. So this is the general procedure for the microgrid simulation process. And for our solution here, I will show you later in our tool. But in our tool called PSDE, so in our library, we have already the model of grid, a conventional generator, photovoltaic, wind, energy storage, load, fuel, gas turbine, gas motor, absorption chiller, and thermal storage. And we have also the irradiation of the solar, of template, temperature for solar, and we can input the electrical load, thermal load, wind, and the energy cost and power limit. And here is the model of the grid of the conventional generator, the other, and then we make the simulation. And the simulation here, we give out the output. Let's say the financial tool, let's help you to provide the stakeholder specific PPA structure, CAPEX, OPEX, debt and equity structure, annual escalation. And also the trend, the financial technical KPI, and customer report. I think it's for you have clear. I give you here an example. For example, you have microgrid like this. So maybe now you in your microgrid is you have the 9 diesel generator here, and you have load here, residential load here. So the maximum is 5,300 kilowatt, and average is like 3,292 kilowatts. And this load will be increased, let's say 1% per year. So now you have this, and now to think about that, okay, your grid, now you want to integrate the solar, and if you want to integrate the solar, the question is, what should be the suitable size of solar? And of course, you should have some data from the solar potential. And the next question is, do you need the energy storage? And if you need energy storage, and which and the technology of the energy storage will impact to your financial KPI, how is impact, and what is the size of energy storage? And based on the typical daily load here, yeah. So the question I show here is a simple microgrid. And with the basic question is, what is the size of PV? And do you need energy storage? And if you need, how could be what could be the size of energy storage? So by running the PSD I mentioned above, so you can see here. Let's say the result that you can see from the tool which we do, that we have the typical daily load here, and we have the total load, peak load, and something like this. And here we have the financial target. For example, for when you invest to the project, is the very important KPI is return of equity. And so let's say here you want to have the target is 15%, and you have to get the credit from financial organization or from bank, let's say 70%, and you have your own money is 30%. and the interest rate of the debt from is let's say 7.5%, and you have to pay back after 14 years. Let's say that the cost increase is 2% per year. The cost here you can see here, it could be inflation, it could be O&M cost, maybe it could be fuel cost, and electricity tariff is the cost. So this is the input of financial input which we want to reach. And the question is, to reach this target, how is the CAPEX and the other financial KPI we should have? Here you can see in the table here the different scenario. Okay, so the first scenario is current status now that you have only diesel generator. And the next scenario is you have diesel generator plus 2.4 megawatt from solar. And the next, you have diesel generator and you have solar 4.8 megawatt. And the last scenario is the diesel generator, solar 4.8 megawatt, and you have battery 1.1 megawatt and 0.3 megawatt hour. So for each scenario here, we have the financial KPI. For example, for CAPEX, because you have now the current, do not invest anything, so that's why the CAPEX is 0. But the next, the CAPEX should be 6.5 million USD. If you want to investigate more PV, you have to invest more money, so 10.5 million. And for diesel, you need to invest more for battery. And here we have the operating costs of the first year. You can see here the difference, the operating cost of each scenario is reduced. And the PV use in percent of total energy. So here, let's say in this case, the PV use in this scenario is only 12%. In this scenario, it's 21%. And in this scenario, is the 22%. But the curtain of the PV, so that means you have to cut off the PV is here, the different here. And the price of year one, this electricity price is here, and the levelized cost of energy over 20 years. So we calculate the levelized cost of we calculate the project for the lifetime of 20 years. So let's say that so this is, we help you to select, to find out, okay, I want to investigate this. We can select the most suitable scenario to your based on your expectation or expectation of investor. So let's say here we select the last scenario, and then now we should have the model of this. So here we have PV power plant, here we have energy storage, we have generator, and so on. So, and based on this, you should have here, maybe it's difficult to understand, but you can see here, this is the time frame of between 1 day, typical load, and this is the generation mix between different sources. So you can see here the PV, what should the PV generation curve, or the diesel generation curve, and also battery generation curve. Okay, so now I would like to show you let's say the more detail in my in the tool. So in the tool here, you can see this is the tool. Can you see my screen?
Yes, yes.
Okay. Okay, so this is the tool which we have. So let's say we talk about the resort here. You can see here the tab to declare the resort, and let's say you want to have the PV. So we have the PV here. We can put in here the latitude and longitude here, so you can get it from Google Map. And in our software, we buy the solar irradiation data from third party, and you can get the data, the weather data for solar for your calculation. So this is, you can see here is direct radiation irradiation here. So you can select the input here. You can select the wind speed. Wind speed, we do not have GPS, but we can put here as a CSV. And this is like the CO2 price. If you have CO2 price, you can put here. And next is the equipment. So I will go quickly because in the equipment, you can select the different equipment here. So if you have steam turbine or photovoltaic and wind, and you want to have the energy storage, so you can select it and drag and drop to here. And for example, for gas turbine, we have very detailed information about gas turbine. For example, here you can have an input the let's say for example lifetime of the gas turbine, and you should have the operational cost. So very detailed thermal and also operation and technical cost for each element. We have CAPEX, OPEX cost of each element here, and also, for example, for the energy storage, we have very detailed data here, and all this input data, very detailed input data, to ensure that our financial analysis is with a high accuracy. So after that, you can select the network topology. So the gray one is the electrical, and the red one is the heating, is thermal load. You can combine between or optimize between electrical and thermal load. And here in simulator, you can select that, okay, you want to have the project lifetime 20 years. You set some schedule here, and here you can set the different scenario. So sorry, here is there are here different scenario. Here is the size, define the size of define the 5, 10, 15 or 20. Here is the number inverter of the solar. Okay, and then you can calculate it with different and different scenario. And here, before you calculate it, you can have to set the input data for the financial input, financial input. So you maybe you have corporate tax target, return of equity, the WACC, and the debt, the interest, and the repayment period, and there are some grace period and some fee here. And this is a reserve accounting about the debt service accounting. And here is the timeline. For example, you want the project start from 2020, contract time is two years, and production time is 20. And here, so this is the input financial. You set it, and then you run the simulation, and you can see here the different scenario here, and you can see a lot of detailed result here. So for example, in the result here, you can see here. So you can see the cash flow. This is the cash flow in detail, and this. And you can see here a lot of comparison. You can see the operation expand, net cash flow, and revenue. And you can see, compare the different scenario, and you can compare the stakeholder. So this is how how detail of our financial KPI can be calculated. Okay, so this is let's say, okay, after certain amount of financial analysis and calculation and so on, we select this scenario. Okay, so then let's say we have this this scenario, and this scenario need to be verified in the electrical technical point of view, because we are not sure that this electrical system can operate smoothly and can fulfill the requirement of the power quality or of the grid code or requirement, so on. So that's why the next step, we need to go to the technical analysis with PNS Sincal. This is the second step here. And here we have the network, and this network must be investigated in the technical study. So the first is the load flow short circuit investigation to design the electrical plant. Let's say how big of the transformer, and how sizing the cable, the length, optimize the length of cable, cross section of the cable, and so on. Also calculate the short circuit for select the circuit breaker or for the protection coordination. And the other is steady state study. Need to check whether about the harmonic, the power quality, and if you have the power quality problem, you need to design the harmonic filter. And we need to see the reactive power compensation. We need to correct the power factor. And if you have problem, we have to go through the counter measurement. Protection coordination is very important to keep to protect your network against the fault. And the dynamic study is frequency stability, voltage recovery, generator stability, impact of generation control, and last but not least is the design of load setting scheme and support upload for frequency stability, because it's very important to take a very deep view in the microgrid, and we need to make the priority list of the load, because in the worst case you need to set the load, and you should set the load with the less priority level. Then we can keep your microgrid survives. And this is the system study, and for doing this, we are using the PSS Sincal. So PSS Sincal is a simulation software for analyze and planning or network type, and it's used now in 90 countries in the world. In Southeast Asia, we have big customer in Indonesia, in Vietnam, and in Singapore, also in Thailand. And this is the software have a lot of module to make the study in the for the electricity network, and for sure it can be used for microgrid study. You can see here the power flow, short circuit, and we have the contingency analysis and -1, or the other like load balancing, or for dynamic we can simulate the stability for frequency stability analysis, many other stability issue like voltage stability, rotor angle stability. And we can this can also investigate the electromagnetic transient. For over switching transient, we can have the other module like frequency domain like harmonic contingency, and of course we have the protection for the network, and for the other strategy module. For you have more view in this. So let's say this is the example of microgrid in PSS Sincal. So if you can see here, I prepare the network here. So this is the, let's say a network of a quite complex microgrid here in Sincal. And this is, you can see here, we can have the model of wind. This is the model of solar, and this is the model of energy storage. And we even have the model of charging station. Yeah, charging station for car, yeah, e-mobility, yeah, e-car. And we have, of course, the model of conventional generator, and so on. And let's say take a look here. If you can see here that if I come back to this network, this result, you can see here. This is the curve of this is the curve of PV. The curve of PV, and the curve of the other generator, and the curve of the load. So how can you integrate it into your study? And you can see here, you can integrate into the solar, the result from the financial, from let's say from above financial study. So this is from actually from weather, but let's say from battery storage, you can have the charging curve here from the result from the former step. And then you can run of course, you can inject here the typical load. The typical load here. So this is the load here. You can inject the typical load here. So after that, you can run the load flow. You can run the load flow, and you can see the result of different scenario. For example, here you can see it in the let's say the so you can see the time here, the different time here, and you can take a look into the chain of the network based on the color, because the load flow here we follow the curve here. And for the other thing is you can calculate the harmonics. So this is something like harmonics. You can calculate the TSD here at each node. You can calculate the TSD here, and you can see here the dashed line here is the requirement, and here you can see at the harmonic of this node is very high. We need to have, let's say, the harmonic filter, and moreover you can have the protection coordination. So you have the certain number of the element here, and this is the protection coordination code. There are many other study we need for microgrid. Here I just show some important thing for you to have the. So come back to our grid. So our grid now we need to simulate it into the Sincal, our software. And so let's see here. This is the model of our network in Sincal. Yeah. So you can see here. Here is photovoltaic. We have the energy storage. We have the 9 decent unit, and we have load here. And here is an example of frequency stability with and without energy storage. So we check whether the energy storage how good of energy storage respond in our network. So in this case, we make assumption that okay, we put only 6 decent unit into operation. Okay, and we have 2 PV unit in operation. And what happened if we lost 1 unit of photovoltaics? And you can see here we have 2 curves here. So one blue curve is without energy storage, and the red curve here is with energy storage. The black line here. The black line here is so the 47.5 Hz. So this is the let's say the critical frequency. So the frequency, the requirement that the frequency of the microgrid network is not allowed to go below this 47.5 Hz. So you can see here in the blue, the frequency it cannot fulfill the requirement. But energy storage, the frequency is keep above. You can see here at this moment is the energy storage discharge the active power to keep the frequency above here. And at this moment, the energy storage is out of charge. They use all of the energy. and they start to recharge. So that's why when they start to recharge, the frequencies go down, because the energy storage takes the power from system, and they consume the active power. So that's why the frequencies go down. But at the end, the frequency come back to 50 hertz and stable. So this is how we check the response of the energy storage in dynamic simulation, to see that from point of view, from frequency stability point of view, our energy storage is good or not good. And the same idea here is we have 6 decent unit and 1 PV only, but then we lost 1 PV, and with and without energy storage. So with energy storage, we still can keep the microgrid survive after we lost 1 block of photovoltaic. So this is one example of frequency stability in for microgrid. We have the other topic like black start and motor start and so on so far, and this can be done in the PLS Sincal. Okay. So let's say after that we check that, okay, so our network is okay, suitable for financial selection, and from technical point of view, this can run operate smoothly, and so on. And we decide to contract it on site. And now we need to have the tool or the product to control the microgrid and also monitor it. So we go to the next solution is microgrid control with MGC and MGMS here. Okay, so this is MGC, MGMS, and also including the performance guarantee of the microgrid. So what is the MGC? MGC is sort of microgrid controller. So microgrid controller based on CCAM, and this we apply for very basics the microgrid. Let's say very simple microgrid, let's say 1 solar, 1 battery, and 1 diesel, 1 block, some block of diesel and load. So the area or the configuration of microgrid is simple. Then we can use the CCAM, and the CCAM can monitor our access, monitor PV panel, or monitor the loading of the transformer, and can also automatic start the backup generator, reserve management, peak saving, and state of charge management for energy storage, economic and environmental index. So this is for CCAM. The next one is for more complex microgrid, like us in the microgrid I saw in Sincal, the PS Sincal. And if the network is bigger and more complex, we have the spectrum power file. So we call MGMS. It does mean microgrid management system. And with this, you can have the monitoring here, very different monitoring here, grid monitoring and control, access monitoring and control, load forecasting, more function, yeah, renewable generation forecasting, storage integration, firm power provision, and schedule compliance. And you can see here, power balance. Here you can see how much you exchange to the public net, what is the load, and what is the diesel, what is biomass, hydro, wind, photovoltaic, storage, overhead. and how many renewable share here. So you can see it's 80.7% here, and cost and carbon footprint. You can see the weather and you see the status of your network here. And from this, you can also make the performance guarantee. So compare between this index to the what we calculate from the first step, and we can always monitor between planning and measuring, and have to let's say to guarantee that we get what we plan. Okay, so this is the we go to the let's say the last step, but I want to come back here. We have already go to the from PSDE for financial to the PSS Sincal for technical, and for control monitoring and performance guarantee, and it's all the way like a loop. So after we get the information for measurement, when the microgrid go to the operation, we always can make a loop to optimize our microgrid operation. So this is what I want to present to you today, and thank you for your attention. And this is my contacts. If you have, of course, you can have the question now, but after this, if you have any further question, drop me an email or WhatsApp or Line or Viber. I use all of this application. So thank you. I think now is I looking forward for your question.
Okay, thank you, Dr. Mao. There is one question. What is software that you use to simulate? I think this question is about the first software, PSSDE, which one that you use to evaluate the financial situation of the project before we begin, right? Could you explain more about it?
Yes. For financial, we use the software named PSDE. So PSDE, you can see, I don't know where you have the photo here, but this is the tool of the PSDE. Okay, so this is the software called PSDE to evaluate or to analyze the financial. Yeah.
So actually, I have question about the feature of this software as well. Mm-hmm. You mentioned that your PSSDE can evaluate the financial point.
Yes.
And you show that the software can do many important points, can mm-hmm. evaluate many important points, especially the case that you install the solar farm, mm-hmm. and you show some example, like when we have to place the solar farm somewhere, and you can use the latitude and longitude from the Google map. Could you show me again or discuss again how you evaluate the financial for the solar PV farm installation?
Okay, so firstly, you can see here here we have the resort, yeah. So we can add more resort here. So and then if you want to investigate the solar, so mm-hmm. you need to input the, let's say, the solar potential, and the solar potential is based on the irradiation, right? So this one, yes. Okay. And in this PSDE, we have bought the data from third party. They have the data of irradiation worldwide. So what mm-hmm. you have to do, you just have to click here, and you put here. You can search by streets or search by city or country here. or you can put here is the latitude or longitude here. Okay, and then after this you just select the location. So this map we show up the location, and after you select it, all the irradiation data of this selected the location will be used in PSDE for calculate the let's say the energy produced of the solar. And of course this is only the weather data. And now you need to go to the equipment. So because you have here the photovoltaics, so you have the different size, different photovoltaic system. What you have to do, that you prepare the access. Yeah, this is the type of access you need to prepare, drop and drop here to talk to the software that okay, the access in your network, in your microgrid have the internal PV. Okay, so let's say here I already have the PV central inverter here. Okay, inverter here, and then you can see here you have to put in many other information about your PV. Okay, so about temperature, many about the sizing here, about the loss here. If you go in detail, is here. So many things, loss and operation and many other information for financial calculation and so on. Okay, so yeah, many, and also the efficiency reduce how many percent per year and so on. This is for PV. So all this input data will be used for the calculate, let's say the CAPEX, the OPEX, and the other thing like IRR or NPV. The same thing is also for steam turbine. And here for steam turbine, there are many data need to be used for financial. And this one is this software involve our Siemens colleague in the power and generation department, because our colleague in power and generation, they have they make the model for the cost calculation of the gas, of steam, and so on, because they have a lot of data, a lot of experience in modeling the gas, steam, turbine, and so on. And that's why you can see here the data, the input data for steam or for the gas turbine is very detailed.
Okay, there's some question from the audience, like in case we have our own solar irradiance data, can we assign or upload
yes, we can
to the
do
software? Okay.
We can
and
do
how
it,
about
yes.
other data like generation or PV data characteristic, so we can adjust in the software?
Yes. So this is one way for GPS location, is only one way to inject the input data. But if you have the, let's say, CSV in the CSV format and so on, you can still put it into to this software. Like
and there is one question about the software, whether it's paid for use or you have like a trial version for this one, or evaluation for research or something like that.
This software is for only our internally, so we do not sell out of the Siemens now. So if you want to have, so I know it could be said when you hear about this, but if you need to have the detailed financial investigate, so we need to do it together. Yeah.
Okay.
It's not like the power system simulation software that you can do it alone, but here we have to do together.
You mentioned actually in your abstract that 15% of the investment goes for the controller, like the one that you mentioned last of your presentation is about the MGC and MGMS, right?
Yeah.
So are those like the key to your automation or like controller? So how
I
you
think
can apply it?
Yeah, the thing is this is only the estimate maximum. Yeah, because the controller here is very important for keep your microgrid work smoothly. Okay, so this is only like estimate maximum, but it depend on your let's say the configuration of your microgrid, and what is the function of the control system you want to have. So if you want to have all the function, of course the cost will be increased. But if you just want to use some basic function, so you can have the less cost.
I see. So actually, for the controller that you introduced in this presentation, just like the one that we can set up later, according to our requirement to operate the microgrid, right?
Yes.
Okay.
Yes. For example, in some some microgrid, yeah. For example, in Germany, I think I already presented in the other IEEE section, I think 2 weeks ago. There are one microgrid in Germany, and this microgrid have to provide ancillary service to the public network. So that means they need to provide, need to support the frequency stability. They need to support the voltage stability at the point of coupling point to the public grid. And with that, you need more function of for the control system or management system. Yeah.
Okay. I think the point that you mentioned in the presentation has lots of detail, I think, and maybe today just some excerpt on how we can think of the implementation of the microgrid and how we can make use of the microgrid in the realistic application, right? And
yes.
maybe okay, I think maybe I can wrap up something because microgrid can serve many applications according to your presentation or some research about in this area. Anyway, I think many audience could provide us some comments if you want, and questions. In case you want to contact Dr. Mao, you can contact him at the email that you give. You can show your last slide. Yes. Okay. And in case you have a question or you want to ask for something else from Dr. Mao, you can contact Dr. Mao at Siemens. And maybe it's the end of the presentation. Okay, let's thank you to Dr. Mao for your very interesting topic and presentation. Okay, and I hope everyone can make use or make the most benefit of this webinar, and we can have a time to catch up later for the meeting, for the webinar, next webinar. Thank you.
Okay, thank you a lot for your time, and thank you, Dr. Chandai, for your moderation. Yeah. Thank you.
Okay. Okay, thank you, everyone. In case you have other questions, you can still leave your question at the group chat, and or you can send an email directly to the Dr. Mao. Okay, for further contacts. Okay, you can see from this slide that Dr. Mao give you the email, and also in case you want to contact him through the phone, you can just call him through this number. Okay.
Thank you.
Okay. Thank you.
Thank you very much. Yeah. Bye bye.
Have a good day.
Have a good day. Bye.
Bye bye.